Interesting, right? So they're telling us right now that they're telling us, notice that they say that that's an isothermal compression. This is the first time we really know that it is. We could have calculated that it was and guessed that it was, but they're telling us that the process BC is a isothermal compression, okay? And so let's just draw a picture of that thing, right? Here's A, here's B, here's C. Wank, 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 right? So, I'm sorry, CA. The process CA is an isothermal. Let's make sure I'm saying the right thing. I'm not just tripping here. Yeah, the process CA is isothermal. This is beautiful because this means it operates at a constant temperature, right? The temperature is 400 kelvins, right? So basically what they want to do, and again, why this is 2 marks, I don't know, right? But the gas is compressed, right? So the gas is compressed, but the temperature stays the same, right? Normally the temperature would rise, okay? So temp is constant. That means this implies that heat flows out. So our this work, right? Okay, is going to be the work is actually going to be negative, or the heat flow is going to be negative 1390. And here's how I know that, right? Change in U is equal to whoops, that's not right. Change in Q, the Q that flows, right, is the change in internal energy plus the work, right? So the work is negative 1390 because it's work done on the gas, right? Remember, positive work is the gas does work, right? Okay, delta U is 0, right? So delta Q is negative 1390, okay? And so now we've got, yeah, that's good, right? So we've got that the Q is negative, that's our Q, right? And then remember that S is equal to delta Q over T, right? So there you have it. Be sure, if you've got a minus sign, put it on there. Be sure to put the right units on there. All right. Then it says determine the efficiency of the cycle ABCA, right? Well, at this point, I was just sort of like going crazy, right? So I figured out for AB, for BC, for CA, right? I figured out the Q that flows in, right? I figured out the work, right? And I really could have saved myself. I could have saved myself some time, right? But anyway, the work, yeah. Okay. So CA, yeah. So this works, right? So write these all down. This is process CA, right? So you put the negative 1390 there. BC, of course, is no work. AB is, didn't we figure out it's positive 3,000 or something like that, right? So you figure that, I don't want to give that away too much, right? And then basically it's the heat that flows in. It's the 7.5 kilojoules that flows in that, and I think we got 7.5 kilojoules. That's what we get for the thermal energy transferred to the gas. So this is B letter 3I. Right, the answer to that is like 3,000 kilojoules, right? Okay, no, sorry, 7,500 kilojoules, right? So 7,500, and that's what matters, right? That's the heat that flows in, and then efficiency is output over input, right? So it's going to be what, 3,000 minus 1390 over 7,500, right? Will give us our efficiency. Okay. And then it says, state whether the efficiency of a Carnot engine operating between the same temperature as those would be greater than, less than, or equal to the efficiency in D. Well, this is not a Carnot cycle. Here's our reasoning, right? That's not a Carnot cycle because Carnot cycles have curvy lines all around it, right? Okay. And Carnot cycles are the maximum possible efficiency. So that would lead us to a certain conclusion. Right? If Carnot cycles are the most efficient, and this is not a Carnot cycle, right? Would it be yeah, you can answer that. All right, good enough.